Today we're revisiting the Arduino controlled CNC router that I built a while back. I documented this build with day-by-day steps should you choose to look at my channel and see the build. We'll talk through the constituent parts that we see today, and then the aims and objectives of today. So this is the 3-axis X, Y and Z axis computer numerically controlled router. There's a tiny router bit inserted in the router. This is a do-it-yourself router. Suitable sleeve and collar to accept the router bit, and the plan is to carve wood. So how do we control the CNC? Well, we've got an Arduino Uno with what they call a shield mounted on top. This shield has channels, for one for the X, one for the Y and one for the Z channel. You might be able to see that. X, Y and Z channel of wiring. So each stepper motor has 4 wires, and that controls direction and amount of movement of each stepper motor. All of this is controlled by a trusty Windows laptop running software called Easel. Fantastic software, free for do-it-yourselfers. You can upgrade, of course. USB cable from the port to the Arduino. .24 steadily input. A separate power supply for the router. Piece of wood attached there's our table attached to the Y-axis. So the router's attached to the X-axis and the Z-axis, and the table is attached to the Y-axis. A vise would be used on this table, securely bolted down, so that when the router's doing its thing, i.e. routing a star-shaped cutout in any wood. When the router's doing its thing, the wood is held firmly and level. What's this piece? Well, I wanted to map out how far, if this was the home point, how far is it possible to route, and it turns out it's 8¼ inches in the X direction and a similar 8¼ inches or 21 centimetres in the Y direction. Double-sided gaffer tape. We'll just attach the card and board for us to see the router in action. Some of you used to be thinking, well, why don't you just attach a pen to the router and we can see the path? Well, I haven't. I want you to be able to visualize. This is the path. That's the original drawing. Let's see a test carve with no wood involved. So you're visualizing the router being switched on, making a noise and routing this shape on a piece of wood firmly attached to this bed. What will we see? Well, we'll see the X and the Y and the Z as the table moves backwards, forwards and up between passes. This is set as the home point, 0, 0 on any drawing, and that's the point the router will return back to at the end of each cut. Without further ado, let's have a look at the test carve. So we're using the easel software, and we go through the steps. I'm just going to take the defaults. We're going to say that the spindle is on. I'm going to press carve. A warning is going to come to keep an eye on it. I'll close that warning and we'll watch this as it goes through the motions. So it goes to the start of the star, down into the wood, and then it proceeds to move X, Y and Z axes to trace the shape of the star into the wood. We can see the X, Y and Z channels lighted up as the Arduino G Shield controls each stepper motor. We can see the spindle moving, and the Z will only move in between passes. These are the amps being drawn by the stepper motors, but they're not under load because it's not cutting anything at the moment. I've gone for this quite powerful router with a variable speed control to give me a choice, and it's gone back to the home position 00, and Easel has asked if it worked alright. So we now know the size of piece that can be machined on these 300mm rails. "12" rails give a working area of 8¼ inches, or 300mm rails give a working area of 21 centimetres, or 210mm working range. I don't envisage cutting to the very extremes of the machine, but it's useful to know when positioning your piece. Hope you found this interesting. It's just an update. I suppose the next step is to move all this into the workshop, clamp some wood onto the table, and off we go. Thanks for watching.